All right, so we've talked about polynomial graphs and some things about polynomial functions, and we've talked about how to solve polynomial functions. So now we're going to talk about how to kind of put those skills together and graph polynomial functions. So a few things that we need to remember first off. We need to remember about end behavior. So odd and even, positive and negative. So remember, odd means we have ends that are going opposite ways. And these all have to do with like the arrows on the ends, right? So odd is opposite ways. Even means our ends are going the same direction. And then positive and negative refers to what is happening on the right side of the graph. And remember, both of these pieces of information can be found from the leading term. Okay. And then also we want to talk about the types of roots. So we have talked about this before, and we touched on this in class today. So single roots are going to pass through the x-axis. So like these are examples of single roots. Each one of those has its own single passing point, and it just passes through the axis, right? And then we have what are called double roots, and we talked about this like we said today. We've talked about it before with parabolas. So double roots are what we have like a touch and a turn. All right, they bounce off of the x-axis and they touch and turn the other direction, so they do not pass through. All right, and the last thing we need to remember are y-intercepts. So remember, when we have something in standard form, so let's say it's I'm just going to add some extra variables here. So like, let's say it's ax to the 5th plus bx to the 4th plus cx to the 3rd, and we're going to like keep going. We remember it's this number at the end that does not have an x that is usually our y-intercept. All right, so like if this is 5, then my y-intercept is going to be 5. Well, y-intercepts occur when x is 0. And that should make sense, because if I plugged 0 in for all of these, all those terms would become 0, and I would just be left with the constant term. Also, if I plot the point like 0, 5, that's going to end up on the y-axis. So the thing that we need to remember today is that y-intercepts, and this needs to be clearly stated in your note, occur when x equals 0. So we're going to use that as we're graphing today. All right, so let's take a minute to look at a few examples. So we're going to sketch the graph of this one, so you can call this example 1 in your notes. The first thing that we're going to do is we're going to identify positive or negative. So I'm going to look here at this leading term and just look to see, is there any sort of reflection on the front? So this does not have any number out here. If it did, there would be a number in this spot, like a positive or a negative 1, or maybe a different number, and this doesn't have one. So this is positive, which is going to tell me that on the right, I have an arrow that's going up. All right, I don't know anything else, but I know that part so far. The next thing we're going to do is we're going to list our zeros. And we want to identify or roots. Remember, we can call those roots as well. So we're going to sit here and we're going to look at all of these different factors. So this is kind of that skill we were practicing yesterday. We've been practicing where we're setting everything equal to 0. So I notice I have a root at -6. I notice I have one at -2. And then if I solve 2x minus 4 equals 0, this is going to give me 2x equals 4, or x equals 2. So I have another 0 at 2. Okay, and with that, one thing that we want to note is, are there going to be any doubles? So we find doubles by looking at the exponents here. So notice I see that this has, these parentheses are squared. That really means that this set of parentheses is written twice, which means that -2 here would be a double. So what I'm going to do is identify that this is a double root. All right, now, zeros get plotted on the x-axis. That's where we find zeros or roots. So I'm going to go ahead and plot these points. And your graph doesn't have to be perfect, but you should label where these points are that you're graphing. All right, and then I usually do put like an extra circle around any doubles, because it's going to change how we interact with the x-axis at those points. All right, and the last thing we need to do is figure out what our y-intercept is. And so what we had just told ourselves is that y-intercepts happen when x equals 0. So I'm going to look at my graph here, and I'm going to evaluate what happens if x is 0. Okay, so if I plug 0 in for all of the x values, and I'm not going to write this every time because it should be You should be able to skip some of these steps in the future. 0 minus 4. All right, if I look at each one of these parentheses, if I plug in 0 in the first, I get 6. If I plug 0 into the second set of parentheses, I get 2 squared. And in the last factor here, if I plug 0 in, I'm going to get negative 4. And I can use the calculator to help me with this if I need to, but this is 6 times 4 times negative 4, which is going to give me 24 times negative 4, which I believe is negative 96. Okay, so remember, this is our y-intercept. So on my graph, I'm also going to make a point down here at negative 96. So again, your graph doesn't have to have all these tick marks on it, but you should have labeled these 4 points with the numbers that we've graphed so far. All right, now that we have everything on our graph, we're just going to connect. It's just kind of a game of connect the dots at this point. All right, so I have my up arrow over here. This is not going to look super beautiful. We're going to do our best, though. Okay, so we're going to come down, pass through. All right, pass through. And then we have a double here. So at this negative 2, my graph is going to bounce and turn back around. And then somewhere it's going to have to turn so that I can go back up and out the other side. All right, so my graph looks something like this. One thing that I do know is that now I can check, is this an even graph? Is this even? And if I go back and I count my roots right here, I should see that I have 1, 2 right here at the double. So 1, 2, 3, 4 roots altogether. So this is an even graph, which means my graph is done correctly. All right, let's do one more quick example. All right, so we're going to walk through this one pretty quickly. We're going to start in the same place that we did the last time. We're going to identify that this is a negative graph here in the front. I notice this negative coefficient. So that means I'm going to have a down arrow on the right side. Then I'm going to go through and identify my roots or my zeros. I see that I've got one at negative 4, which actually happens to be a double. And I have another one at positive 5. And then lastly, I'll go ahead and make those points on the x-axis. So I've got negative 4, positive 5. And then lastly, I'm going to look at my y-intercept. Remember, that happens when x is 0, so this becomes negative, parentheses. If I plug 0 in the first factor, I get 4. If I plug 0 in the second factor, I get negative 5. And again, I can use a calculator to work this out if I need to. I honestly just don't have one right now. All right, so this looks like it's going to give me positive 80. So I'm going to plot my y-intercept at positive 80. All right, now I'm just going to play a game of connect the dots. So I don't have any, I do have a double. I should have put a circle around that one. This is a double. So on my singles, I just pass through the point. I'm going to come up here and connect. And then on this double, I'm going to come back and bounce and go back up. I notice then that this is odd, so I just want to check, is my graph odd? Yes, I have 2 roots right here with the double and a third one right there at the 5, which means this is an odd function because this would have been x to the third if everything were multiplied out. All right, and our last quick example is just going to go the other direction. This time they have given us a graph. And they could give us a table, and there's a few different ways they could give us this information, but in this example, we're going to start from a graph and write an equation from that. So a few things to know as you're sketching a graph for yourself in your notes. We've got a point of interest at negative 1, a point at 2. I've got a point down here at negative 12. All right, so we're going to work this literally backwards of what we were just doing when we graphed. I note here that this is going down, which means I should have a negative leading coefficient. So I know my function is going to start with a negative number. I don't quite know what that number is yet, so I'm going to leave a space there, but I do know that it needs to be negative. I see that I have roots or zeros at negative 1 and at 2. And I notice that 2 is going to be a double. So when I go to write the factors, if I have a root at negative 1, my factor is going to be x plus 1. If I have a root at positive 2, my factor is going to be x minus 2. And because this root right here is a double, then I need to put an exponent of 2 on that factor. All right, and then lastly, we need to account for the fact that we have this y-intercept here at negative 12. So remember, y-intercepts happen whenever x is 0. So for just a minute, I'm going to put a placeholder of an a value there because I don't know what number goes there exactly. So I know that if I plug 0 in for x right here, I should get negative 12 for y. So this is negative 12 equals negative something times 1 times negative 2 squared. So I know that the 1 times the negative 2, this is something times negative 4 equals negative 12. Well, the something that would have to go there is obviously going to be 3. So I can come back and replace in my original equation this a with a 3, which means my final function, if I just write this out again, is going to be y equals negative 3 x plus 1 x minus 2 squared. Make sure you know any sections that you want to ask questions about tomorrow so that we can go over those things together.